Welcome to my new calculus channel. My name is John Gabriel. So today I'm going to talk to you about the disconnect between physicists and mathematics and the fact that the mainstream calculus is flawed in several ways, but the one way I'm going to talk about is concerning the tangent line and points of inflection. And exactly what is a tangent line. So let's begin. We'll start with example 1, which has a velocity curve, the curve that you see in red, and an acceleration curve that you see in blue. And this little green line here is the tangent line. So now, physicists and mathematicians like to think that there is a tangent line there. So theoretically, the acceleration there is 0, yes? And while it decreases here, the acceleration decreases to 0, and the velocity approaches 1, it increases here. This point here is a point of inflection. So, a tangent line never crosses a curve. It only touches in one point, extends to both sides, and never crosses. So here, it actually crosses the curve at this point, okay? So you cannot have a tangent line which crosses the curve, ever. And that was the original definition. I'll have you know that Webster changed it because I was using it so effectively against the mainstream. That's the editors of Webster. They were coerced by the Church of Academia to change it. So now, you know, this here being a point of inflection doesn't have any real connection with the physical world. And I'm going to show you why in just a second. Let's take another example. So this example now also has a point of inflection in the same spot. And excuse me. And here is the tangent line, the green tangent line, and the point. And we'll notice that as we're approaching the point of inflection, the acceleration increases, and gets very, very large, and the velocity comes close to 1. But all of a sudden, when we hit that particular point, there's no acceleration because t equals 1 means there's a 0 here. So there's no connect here. So while according to the mainstream mathematicians, there is a tangent line there. The acceleration is not defined. So there's no connection between an inflection point and physics. The problem is, though, mainstream calculus is not well formulated, and there isn't really a tangent line there either, okay? It's not a misconception, but misguided thinking on the part of mainstream academics. They do not understand what is a tangent line, and they're unable to make the connection between physics and mathematics. So you can't really say anything about the acceleration there. And if you could, it doesn't really mean it's the same in the physical world, as we saw in this example here. So for example, while the acceleration is decreasing there to 0, what does it mean? Does it mean that there's a tangent line there at that point of inflection? No, there isn't. Okay? And the new calculus handles this correctly. So this is one of the main differences between the new calculus and the bogus mainstream calculus. Also, of course, the new calculus is a rigorous formulation, and the mainstream calculus is not a rigorous formulation. Well, I just wanted to point out that physics is not modeled always by mathematics, and one has to be very careful when, you know, reaching conclusions that, there's a tangent line there, and what about physics being the reason that it works? Nope. You cannot use physics to back up your ill-formed notions in mathematics, okay? So there is no tangent line at a point of inflection. I don't care if your physics doesn't work. It doesn't work here either. Look at that. See? What do you say about the acceleration there? It's not 0. It's not anything. Okay? So I hope you've enjoyed this little presentation on the New Calculus channel. My name is John Gabriel. Till next time, goodbye.